Well, hello everyone, and welcome back to Adrian's Digital Basement. It's Wednesday, so you know what that means. It's time for another midweek mini mail call. We're up to number 37. Blows my mind, it really does. So many cool things are sent in by my viewers, it's just amazing. I'm getting near the end of the last batch of mail call items that I open. That's how it works, by the way. If you send something in, it actually, I keep them all together and I don't open any of them until I open them all in a batch on the unboxing part of these videos. Then I keep everything organized and then I film the on the bench parts. And there can be quite a lag time. In fact, the things that I'm showing on today's video, I actually opened on the 31st or the 30th of December 2020. And some of those things were sent in back in November. So it's now, I'm filming this on the 28th of February. So there's definitely a little bit of a lag time. It comes from the fact that I want to share my excitement and my joy of getting all these cool things from people with my viewers and not just breeze over them and, you know, move on. Here's my stuff I got in 1 month and, you know, one video out of it, because there's so much cool stuff to show that I can make a whole series of videos out of it. I do still have several items that were sent in this batch of mail call that I want to make single bespoke videos about. I don't want to combine them into a multi-part mail call videos, only because they're extra super cool, if that makes sense. And I would like to really focus in on them and make a special video about them. So don't worry if you've sent something in and I haven't shown it yet. You can send me an email if you're unsure and I can let you know like where it is in the production line, and I will be getting to everything. I keep everything on a notepad so that I don't forget stuff. So anyhow, without further ado, let's get right to it. All right, we have a little box here, and this comes from Lee in Draper, Utah. Hi to all my viewers in Utah. I haven't spent a lot of time in Utah. I've driven through little bits of it. And from what I can see, it is absolutely an incredibly beautiful state. And, oh, right, okay. So Lee clued me in to what this is. He has a note here, and he has some stuff. So I am actually quite excited. Let's look at the note first. He writes, Adrian, enclosed is the Videx Soft Switch I emailed you about. So Videx is the 80-column video card in my Apple II Plus, although I bought a clone one, but this is the thing that enables it to switch between 40 and 80 columns. He also goes on to say he included a replacement ROM for my clone board. He did also email some bin files, and he and I were talking back and forth about this. He also included the 6-pin connector for your 80-column board to replace the 2-pin that is on there. So this is like how you connect the signal to the little switcher board. And finally, he included the lowercase chip for your Apple II Plus. This cable is displaying lowercase letters in 40-column mode, which is funny because I actually made one of those myself. This is after Lee and I were talking. Amazing. So in this little bag here is the soft switch board. So this plugs into the motherboard, and there are a couple of video cables here that take the signal and mix it together. There's an IC. He has the 2 replacement ROM chips he has sent me. And this is the video cable that he was talking about, which has the female RCA cinch type jack for hooking up your monitor. So awesome. Oh, and here's a little extra pin connector he sent me so I can replace the one that's on there now. That's only 2 pins. So this is fantastic. Let's get back to looking at my Apple II Plus. All right, I have the old Apple II Plus down here on the bench. And yes, this machine is still working. It's been upstairs. I had it set up there so I could use it, but I brought it down here for this video. So on the retro tank here with the color bars, I have the 40-column display, and on the monitor here, I have the 80-column Videx card connected, because remember, without the stuff that Lee sent, I have 2 separate outputs. This is the Philips monitor that I tube swapped in that video series. It was amber originally and very worn out, but now it's got a green CRT in it, and of course it has a green power LED, plus I modded it for extra sharpness. So we turn on the computer just to make sure it's all working before we do anything. Okay, there is the 40-column display on the retro tank. I know it's kind of blocked by the monitor here. And if I do PR number 3, then there we go. There we have the 80-column display working fine. So let's take a look at the stuff that Lee sent and put this in the machine. All right, so look, these are the parts right here. Let's just get this out of the bag. So we have 2 ROM chips in there. We'll look at that in a second. And this here is the actual soft switch module. Now this was something you get originally for this card, the real Videx card that is. It says Videx right there, but this is definitely not an original, right? This is a modern replacement. And I see there, it's got a socket on the bottom. It's got the two cables. One of these plugs into the card itself. One of them plugs onto the motherboard. And then there's this little harness here, which connects up to one of these connectors, like maybe that one. And it's got the RCA connector on it. So what this does is it looks for the signals from the 80-column card, and then it uses a couple transistors here to just switch between the built-in 40-column video and the 80-column video, so you don't have to do it yourself. Now, when Lee emailed me saying he was going to send this switch, he mentioned that he had some pretty good experience with these Videx clone cards. And he said that a lot of the clone cards have a version of the ROM on them that doesn't seem to support this switcher. So when you try to switch between 40 and 80 column mode, it doesn't actually work. But simply replacing the ROM with a new flashed version will fix that problem. So he has gone ahead and sent me the original Videx ROM, or at least one that will work in my board. And then, as he mentioned in his letter, this is the lowercase character generator ROM for the Apple II Plus. I have an upcoming video where I'm going to be talking about lowercase 40-column support on the II Plus. So I won't be talking about this particular ROM, but thank you very much, Lee, for sending this to me as a little bonus. So what's left to do is install this inside the computer. So this card here in slot 3 is the 80-column card, and here's my little homemade cable adapter, because when I got this card off eBay, it didn't come with this little RCA cable thing here. So I just made this, and the little zip tie here is so I can feed this through the back of the case and it won't pull out. It just sort of stays there, especially when the lid is on. So I won't be needing this little cable anymore. So we'll just pull that off. And I'm just going to pop out this card. Whoop, there it is. Now up here in the top left, this is the connector that outputs the video signal, and also I think it outputs the video switching signal. And this is where I'm going to need to connect that little auto switch board. Now originally the Videx I think had a 6-pin connector here. Mine only had a 4-pin connector, and it's stuck straight up from the board. The problem is, if when this is in the computer and you were trying to connect something to this, it would actually bump into the card that was next to it. So I bent the 2 pins over. So I'm going to go look up documentation on this to figure out which cable goes to which, because one of them, like I said, plugs in the card, and the other one plugs into the motherboard down there. There is a connector. And then I'm going to swap the ROM. So this is the video ROM. I have a label on it. This is the ROM for the Videx card. Now I think it says fixed because I've already switched out the ROM with one that Lee sent, because before we emailed a whole bunch back and forth about the ROMs, he had already sent me the replacement ROM, but I actually burned one myself. But I'm gonna just use his just to make sure that it works and it's the right one, because I can't remember exactly what I did with this, because this was now a few months ago. So out with the ROM that I installed, and in with the Videx ROM that Lee sent in. And you know what? I just decided I'm going to remove this connector and I'm going to install a new one with the correct number of pins, six pins. And it looks like there is one pin, one up from the bottom there, and that's the one that's not connected because there's no trace going to it. So I'm just going to cut that one off. But I'm going to put on a real right angle connector because I bent these over, and because of that, the length is not very long. And if I try to take this connector and connect it on here, it doesn't really stay on, because this connector is designed to push more onto the connector than it can when it's bent over. So let me just do a quick fix on that. And just like that, I've switched that out. Here's the original kind of crappy connector that was on there. That's junk now. And now we have this one, which I cut off the correct pin, so it's all good. I have up here on the iPad the soft switch manual for the video soft switch that was actually made by Videx, and this little board here is a clone of. So what is relevant is how the orientation of this little board is: 2 monitor, 2 RF modulator, which I don't have, and then there's a connection to the motherboard and a connection to the card. And right here it does say 80 column card in, and there are only 2 wires up there, so I guess that's just the way this thing works. And if I move the 80 column card out of the way for a second, down here is the IC that it goes on to, 9334, that one right there. And according to the picture in the manual, it goes in that orientation right there with the little adjustment pot towards the keyboard. So out with the original 9334 chip. Does this have a date code on it? AT81, 1981, it does. And this thing, we pop off the little protection on the bottom. This goes in there like so. Just have to kind of look at an angle to get it all aligned. I am going to use a flashlight just to make sure that I'm getting it into all the pins on the socket. So there we go. This is the connection with 2 wires that goes onto the 80 column video card, and there is a little plug on there, so it only can go on the correct way. And then this connection here is what goes on the motherboard, and if we refer back to the iPad here, it seems that the 3 wires go towards the slots. So there's the connector. It's got 3 wires. It does have 2 little plugs in there, so you can only plug it in. Well, you can reverse it, because there are 4 pins that it goes onto on the motherboard, but the 3 wires go closer to the slot. So of the 2 ways it can go, it's going to have to go this way. So like that. And then back to the diagram here, 2 monitor is the connection on the board that's facing the keyboard. And this is the little handy dandy cord that Lee has provided, and this should do the trick. So obviously there's quite a bit of length here, so I guess I'll do my little zip tie trick to hang it out a slot. So first of all, let's connect it. It's also got a little plug on there, so it can only go on one way. And actually, now that I think about it, I'm pretty sure that this is actually the same connector here as this. So this cable would connect directly to the board. And when you bought the soft switch module, you probably just took your existing cable that came with the card and you plugged it into the module. So I'll just run this out the back of the case like so. And I guess the extra length I could zip tie up or whatever. I'll figure that out later. Okay, I have the 2+'s 40 column output just plugged directly into this monitor. Let's just make sure the 2+ still works and doesn't smoke when I turn it on. Okay, good sign, no smoke. So it is still working. Now that's just off the motherboard's native output. So obviously we're not gonna have switched 80 columns. So I'm turning it off and I will move the cable on the back here. So I'm unplugging the cable and I'm gonna plug it straight into this new little cable. Just leave that sitting there. Here we go, let's turn it on. All right, the picture is dim, but it's there. Now I know that little potentiometer that's on the board here is meant for adjusting the brightness of the 40 column display. There it is. That looks good now. So let's see what happens when I do PR number 3. Oh, there it is. Sweet. We have the display. It is working. And if I hit Control Reset, back to the 40 columns. I mean, it's the simplest thing, right? But this was a big deal. And when I was a kid and we had the Apple II Plus, we did not have the soft switch module, and you had to toggle a physical switch. We had this little metal switch box that you switched back and forth depending on which you were using. We had an amber zenith display, but it had one RCA cable that ran to that switch box, and then from it, one that went into the 80 column card and one that went into the motherboard, and you had to manually switch. We never had the soft switch module, and this is awesome. I love it. Look at that, it totally works. Thumbs up to that, I love it. Now, as I mentioned, the potentiometer on the little board allows you to tune the brightness, because if your Videx card outputs a dimmer signal, I guess this little potentiometer allows you to get them exactly the same. But to be honest, I have the potentiometer opened all the way up right now, and I think that's pretty much as close as it gets. Oops, PR number 3. Yeah, there we go. I think this is pretty much the same. It looks plenty good. So what my zip tie trick is I just want this to sort of hang out the back of the computer, just, you know, a few inches like that. So I'm going to take this larger zip tie that I have in a loop here, and I'm just going to tie this onto the cable. And it's big enough, the little loop is big enough and it's a thick enough zip tie that the cable won't easily pull through the back of the case, especially when I have the lid on there. So there we go, that's about enough length. So there we go, like that. This is enough that when I take this and I feed this through the back of the case, like so, it doesn't easily pull through. Hopefully that's showing up in the camera. And there we go, yeah, I'll just tuck the wire down there out of the way. and everything is great. This machine has been working flawlessly since I repaired it. I put that bus driver transceiver in here, the one I got from China, to take out that stack of chips I had. This thing has been working flawlessly. All the keys are still working. I'm trying to move it into view of the camera. All these keys are still good. The cleaning that I did, I've replaced those keys. Thank you to everyone who sent in key switches. This thing is an amazing computer. Thanks to Stuart, who originally sent this to me. I love this Apple II Plus. This is a freaking cool machine, for me specifically, because it has so much history, and that's what makes it extra special. That's kind of why we do all this retro computer stuff, right? To kind of relive a little bit of the nostalgia and experience the way computers were back in the old days, when you could actually easily repair them. So thank you very much, Lee, for sending in the soft switch there, and additionally this extra lowercase ROM. I have several more videos I'll be making about this machine, talking about the lowercase ROM, some more stuff on this Videx card, some cool things I've come up with here, and also some awesome peripherals for the 2 Plus that I want to show off as well. So get subscribed and watch for that in the future. Okay, so the next thing is a letter. This actually comes all the way from Australia. It comes from Craig, and lives in South Australia. So hi to all my Australian viewers. I think I mentioned this before, that I really got my start in electronics. I was always into just fooling around, but watching Dave Jones' EV blog, that really got me going and started with this. In fact, like a lot of the test equipment I have, the Rigol scope, and I have one of his multimeters, I've learned so much by watching Dave Jones, and it's a testament to what you can do with YouTube. Like, so let's see what Craig has sent me. Some stickers, looks like. He's got a letter here, and he says, "Dear Adrian, greetings from Australia. First off, I have to really say and enjoy your content. I had a 512K Mac given to me with a dead floppy drive with no eject, and I watched your videos, and then the C64 stuff started appearing, and yes, one becomes dedicated. I love your combo of knowledge, repairability, tenacity, and general delivery of the projects you end up with. Great range of topics, to really random computers, to drives, to RAM. I love it. And it's true. It's what I love doing about this channel. I don't just focus on one thing. I'm all over the place. It's like whatever I feel like doing at any given time. And I think that's what makes Mail Call kind of interesting, because these episodes are really all over the gamut, you know, because whatever someone sends me, I take a look at, right? And it might be retro, it might not be, it might be broken, it might be interesting, it might be kind of boring, I mean, who knows? But I still look at it, right? So creates interesting stuff. He says, no sugar-free candies from Australia, sorry, but I did have some stickers made up for a project around computers and consoles I loved growing up and have a cool retro theme. Designed to go on the back of your car, so maybe the Blackmobile might end up sporting a few stickers when you're out of the basement. Keep up the good work. All right, well, let's see. I'm just going to quickly look at what he's got here. All right, so these are the stickers, and I'm using my phone, so sorry about the handheld shooting. But there's an Apple II Plus with disk drives. There's a Commodore 64. This is a C128, or is that Amiga 500? I think that's an Amiga 500. Commodore PET. And there is an IBM 5150 or a 5160. How cool! I've been meaning to get Mighty Car Mod's chopped sticker and put that on my car, because I do love that channel as well. I love cars. Besides computers, I really am into cars. So I watch that channel, and I do like their little chopped symbol. So I was thinking of that. But at the moment, I don't have any stickers on the car. I actually have a car and a truck. So I may need to put some of these on there. Very cool. Thank you very much, Craig. He does have an email address here where he says if anyone wants stickers, they can email him. So I will put that in the description below. I'll put a little clip after this where I show which one of these, or these plural, I decide to put on the back of my car. We'll see about that. All right, here's the back of my car, and I have decided to stick the Commodore PET on there. Hopefully this comes across on my camera. The car's a little dirty. I had to make a clean spot. I really need to take the car in for washing. I haven't been driving that much lately, of course, due to lockdown and everything. But that is awesome. I love it. All right, so we have a little package here, and I actually already opened it, so I know who this is from. But this comes from Mario in Germany. He's a viewer of mine. Actually helped me recently pick up a CRT tester, a new one. I haven't showed it on the channel yet. Came all the way from Germany, so he packed it up and sent it for me after I purchased it, but he threw in a couple extra little things, and I have them in this box here. So let's take a look at what these are. Okay, so, oh, he also sent me a bag of Haribo candy, which are gone. They were the German flavored ones of just the Gold Bears, which I love those. I do like them more than the US flavor, so those are gone. So thanks, Mario, for those. Okay, so two things here. There's a brush here, so I'll have to ask him what exactly this is really good for, but it's sort of like a little scrub brush. It's got main bristles here and a back one there. It's completely in German. So yeah, I guess helpful for cleaning things. And we have a little bag here with some goodies inside. Let's see what he sent along. I think he's already told me what these were. I already forgot. Let's see here. And pin sockets for this, and yeah, pretty cool. So let's take a look at this stuff on the bench. A few goodies from Mario. Let's see what this brush is all about. He told me this brush is really good for cleaning electronics. Looking at the back here, it shows it cleaning teeth on one side, and I guess using the other little pointy side right here to really get in the nooks and crannies in your mouth. But I think that's really going to be great for the electronic parts. Let's pop this out of the case, take a closer look at it. I can't say I've ever seen a brush like this here in the US, but I also can't say I've ever really looked very carefully. Looking at this more closely, there's no way this would go in a mouth. So this, this must be for dentures, right? Is that what's going on in this picture here? Yeah, I think it's dentures. Because imagine trying to stick this in your mouth with this scraping around on the inside of your cheek. Anyhow, that's awesome. Yeah, I think this will be really good for kind of get it in there and really rubbing away the flux residue, for instance, of PCBs, especially the bristles are nice and stiff, which is perfect for that scrubbing action you need for cleaning PCBs. Awesome. All right, next up, he sent this perf board, which is incredibly fine pitch. I'd be curious to know what exactly would connect to this. Perhaps this is made for surface mount components. You can just solder them on, and none of these pads are connected together, so you can just bridge the ones you need, I suppose, right? Does anyone have any ideas? And I'm sure Mario probably told me what to use this for, and I don't remember. Let's see what this little thing is here. I have to rip the bag open because it doesn't have a way to open that any other way. All right, yeah, this is a little prototype board for an SMD component. And clearly this is like a dip spacing here. This would go into a socket like on a 64 and allow you to connect a tiny little SMD chip, perhaps some type of flash memory chip, a little surface mount type. I'm really unfamiliar with all the terms like SOP 16 and the different sizes, 04, 02, things like that. Then we have this little board here, which goes with these components he's sent along. These are most likely just the little legs and stuff. They are. These are the nice round type, so they don't destroy your sockets. And then there are two sets of these 2.54 millimeter headers, two of these, so it would go here and here. And the single row headers go on each of these sides. And I know what this is. He explained this to me. So what goes on here is you take a 40-pin dip socket installed on the top. You install these on the bottom side of the board. And this allows you to plug this into a machine and say you put a CPU into here or a VIC-2 chip, and it allows you to easily connect and disconnect all of the 40 pins. So you would put 40 jumpers on all of these double 2-row pin headers here that would connect what's in the socket through to the motherboard. But then you can take one of the jumpers off if you want to disconnect that one pin without lifting the leg. And I think these pin headers that are on the far sides here allow easy probing or connection of any signals. That's a pretty cool little PCB. I'll have to build this up. I won't do it right now, but I'll build this up, and you might see it in a future episode where I need to troubleshoot a 40-pin package like a CPU or something. And lastly, we have this, which is a modern replacement for the Commodore 8701 and 7501 clock generator chip. If we just show a motherboard here, so this is a Commodore 64 motherboard, and it's this IC right here. So on this particular revision and all the later ones, it replaced a bunch of discrete 74LS logic chips here with this one single IC, which is a MOS 8701. If this is bad or you remove it from the motherboard, the computer doesn't work at all, because this helps generate the clock frequencies used on the Commodore 64. The chip here that he has sent is the modern replacement, so it's a small PCB, has a little IC there, some really tiny little components. And I'm pretty sure that this auto selects PAL or NTSC, I think. So this is an NTSC board. Mario lives in Germany, so this would have been a PAL version if it's not the auto select type. So let's pop it on this motherboard and see if it works. Before I try out Mario's chip, I just need to test this motherboard. I haven't used it in a while. It is one of the ones I repaired. Looks like it had bad RAM at some point. Let's turn this on. There we go. Okay, so this machine is absolutely working. Thumbs up to that. Repair still works. I think I wrote down what I fixed incorrectly because it says U21, but U21 is this RAM chip. And these are the famous MT RAM chips. There are still 6 of them on the board. This socket here in U19 is one that I would have changed. This has the round milled holes. And there's one here that is the other kind of socket I probably didn't change. Someone has previously socketed these 2 chips at some point. And this chip here is in a socket, which is probably something that I did. So I don't really remember if there was a repair-a-thon for this particular motherboard, probably. But it looks like I socketed these 2 chips and that repaired it, probably, at least with this one, since I didn't write down that this chip is bad. Anyhow, let's pop in Mario's chip. Out with the 8701, and which way does this go in? Oh, I see there's a notch here, so it goes in. Oh, that looks a little corroded there. Just a touch of Deoxit there. And we'll pop this in, hopefully the correct way, like so. And we'll turn it on, and what are we gonna get? There we go, we have a working system. So awesome, that works on both PAL and NTSC machines, obviously. At one point, I was able to find these original 8701s from AliExpress of all places. In fact, I think this is one of them because the date on here is 1987, which is newer than this entire board. And the chips that I have bought from AliExpress all came with 87 date codes. I think I got 10 of them. So I have a little bit of a stash of replacement 8701s, which is a good thing because, like I said, without them, the computer doesn't work at all. And these modern replacements are readily available now. Jeff Burt also sent me one, which I didn't test out on video, but it would work the same exact way as this. So there are plenty of alternatives now if you do lose this timing chip. You can figure out if that chip is bad by checking the signals on here with an oscilloscope or probably even a logic probe because you'll be able to see the clock in and outs if you look at the schematics for the 64. And without that chip, if it's bad, you're not going to get the right clock signals on the 64, which means it's not going to do anything. All right, well, I'm going to put this motherboard away, and I see the date here is the 24th of February, and I fixed this board on the 23rd of February, 2020. So exactly a year and 1 day, and it still works. Looks like it has an original PLA and original SID chip, and it's still functional. You never know, honestly, with 64s, when they have all the original chips, especially the PLA, that you go to use it, and it's dead. So thank you very much, Mario, for sending this stuff into mail call. If anyone wants to buy any of these things, I'll try to put a link in the description to whatever is actually available to buy. Not the brush, but the rest of this stuff. If there is a link available and Mario has it, I will put it down below. Okay, so the next one, it's quite heavy. It feels a lot like a very heavy bowling ball, although I know what this is, and it's not a heavy bowling ball. This comes from Chris in Pittsburgh, Pennsylvania. So hi to all my viewers in Pennsylvania. I have a good friend whose name is Chris. He's from Pittsburgh as well, but he doesn't actually live there anymore. So he wouldn't have sent this. This comes from a different Chris. There's a note in the package and a good amount of bubble wrap here, but I don't know how effective the bubble wrap is. It seems like the bubble wrap is not wrapped around the item that's in here. Let me lift this out. There it is. There is a piece of wood that maybe was holding it originally with a few screws and things. I think those have come free because this thing decided it did not want to be held down anymore. There it is. Look at this. It's so heavy. So what this is, before I even get to the letter, is an isolation transformer. Now, hopefully it is okay condition-wise because it got really banged up in shipping. But I think it's going to be fine. I think just these little mounting ears on the bottom are a little banged up. In the note from Chris, he says, Adrian, you're the best. I love your work. Your safety is important to me, so please use the enclosed isolation transformer when you're working on power supplies. Maybe a good time to explain VA versus watts. Thanks and keep up the great videos. Chris from Pittsburgh, PA. Yeah, so I've known for a while that I really need to get an isolation transformer, just for my own safety, really. So much so that I actually recently bought one. And this was one I got at a local surplus shop here in Portland. The problem is isolation transformers are kind of expensive. Now, they're not uncommon. A lot of medical equipment is run on these for like a life safety issue. But the problem with the one I bought here is it only can support 45 watts. That's fine for a very small switching transformer. But for anything that's large, like a monitor or any higher current draw equipment, this little one I bought is not going to work for me. So it has some cables on here, you plug it in and stuff, and I actually have a power switch that I was going to install in it and a little pilot light so that I could tell it's live. But this one that I just got from Chris is way heavier than this. So clearly this thing has a much higher capacity, current handling capacity. And yes, sure enough, this is a 300 VA isolation transformer. So we'll talk about in a second the difference between VA and watts. They're not directly compatible. They can be the same or similar, but depends on what type of loads you plug in, where you need a higher VA rating than watts based on the type of power it's pulling, power factor, stuff like that. But 300 VA is definitely more than this. This could be good for up to like 300 watts, which more than can handle like a 14-inch monitor like that, no problem. So yes, let's take a look at these isolation transformers on the bench. Chris is definitely looking out for my safety with this isolation transformer. Eagle-eyed among you may have noticed this transformer sitting on the bench already, and that's because I actually opened up these mail call packages, even though you're watching this video in, I don't know when it is. It might even be March, to be honest, but I opened this up December 31st, 2020, and Chris sent this to me weeks before that. So yeah, it shows how far behind I am with mail call. Anyhow, I opened this, and of course, I had it, and yes, I hadn't shown it on the channel yet per se, but I've definitely been using this. So when you see me inside a monitor working, I pretty much usually have this thing connected for safety, that is. So let's talk a little bit about what an isolation transformer is. This thing is pretty heavy. I'm going to turn this thing on its side. So it has a big long mains input cord, so a standard 3-prong US plug. What an isolation transformer is it's a transformer like any other, where you have a primary side and you have a secondary side. Primary side being connected to, say, the mains, and the secondary side is connected to your load. Now, most transformers, for instance, say you have a 9-volt AC transformer, like the one inside a Commodore 64 power supply, 120 volts or 220 volts comes in, and you get 9 volts AC out, or roughly thereabouts. It's all about the difference in the number of turns you have around the core from one side to the other. What's cool about transformers, and this applies even to the 9-volt AC type, is that the high side and the low side are separated. They are isolated from each other. They are not electrically connected to the secondary side. It's magnetically coupled. And now there are terms for this, and I think galvanically isolated is one such term, but there is a physical isolation. There is insulation around those windings. It's usually an enamel, and there is no electrical connection. I'll link to a Wikipedia article, if I can find one, I'm sure there's one, on more detail about how transformers work. And I'm sure if you just Google for it, you'll find tons of resources explaining it much more clearly than I am. Now, when we talk about something like this transformer here, that's an isolation transformer, the special thing about this is the primary side windings, that's what's hooked up to the mains here, and the secondary side windings, there's a plug, I didn't even talk about this, there's a regular mains plug right here. The number of turns on the primary side and the secondary side, it's the same. And that means that the voltage that comes into this thing through this mains cable here, so I plug this in, I get 120 volts, will be the same as what comes out of this. But they are going to be electrically isolated from each other because of the way a transformer works. The benefit for that is all about safety. if I plug a lamp, for instance, into here, but if I grab onto the live or the hot wire that is hooked up to the secondary side on that lamp, say there's an exposed wire and I touch that, well, I'm not going to get a shock if my other hand is touching something else in the house that is referenced to the power in my whole house. Basically, if I touch something that's like the ground or the neutral on the outlet cover, normally you would get a shock. Well, I have ground fault interrupt outlets down here in the basement, so it would shut off the power, but I could get a shock, say if those weren't working or I didn't have those. But with the isolation that's happening here, all of the 120 volts the lamp is running off of, or if I plug a monitor into it, the monitor is running off of, all of the voltage that's in there is not referenced to the rest of the house and all the grounded outlets and all the neutral wires in my house. It's only referenced to the secondary side of this transformer. It's a little island, a little isolated zone of power, basically. One thing to consider too is just because you have an isolation transformer, it doesn't mean that you can't get a shock, because inside of that monitor is going to be a live and a neutral wire. If I touch the hot with one hand and I touch the neutral with my other hand that's plugged into this outlet, I'll still get a shock. There is still 120 volts of potential between those two wires. Now, if I flip this around like so, there's a metal label. Let's zoom in on that. It's made by Hammond Manufacturing out of Canada. That's pretty cool. One-phase transformer, type X, whatever that means. 171C, maybe that's the model number. And here it is, primary side, 150 volts, 50 or 60 hertz. Secondary side, 115 volts and 300 VA. We'll talk about the VA in a second, but basically there it is, confirming that the primary side and the secondary side is the same. It has the same number of windings inside. That's what makes this an isolation transformer. Now, I can hear people saying it now. Yes, all transformers isolate. I think I kind of explained that a little bit before. That's just the nature of a transformer. It's just the fact that the number of turns on this, the primary and secondary, are the same. Therefore, the voltage in is the same as the voltage out. You could hook this up backwards, and you're still going to have the same voltage in as you have out. Now, right here, you see it says 300 VA. VA stands for volts times amps, and that is a capacity rating of the transformer. Now you might be asking, what exactly is VA for a power rating compared to watts? Watts are pretty much what we work in when we look at electronics. You know, you look at the label on something that says it uses 10 watts of power, for instance. Watts as a measure of power and VA as a measure of power sometimes can be the same thing. So this says 300 VA as its capacity. Well, that could mean 300 watts is what this thing could handle. Sometimes, not always. Now let me attempt to explain why, and I'm not sure that I'm going to give a good explanation here, so I apologize if this doesn't make sense. There are lots of online resources that will probably give a clearer explanation. So as I'd mentioned, VA stands for volts times amps. If you have a device that uses 1 amp of current and it's running on 120 volts, then the number of VA that it's consuming is exactly 120 times 1, or 120 VA. And remember, the transformer right here is 300 VA. It can handle something around 2.5 amps at 120 volts, and that should fit within the rating of this transformer. But when you look at the labels on things, it doesn't talk about the number of VA. It talks about watts. And to calculate watts, watts is simply the VA, volts times amps, times the power factor. And power factor is an important number. Let me try to explain what power factor is a little bit. So imagine you have a sine wave of the 120 volts. So this is the mains voltage here in my house. Terrible sine wave. Just imagine that's how it looks. If you have something that has a power factor of 1.0, which is a perfect power factor, it can't get better than that, it means that the current draw of that same device follows the AC waveform perfectly. You notice I've tried to draw the same waveform twice. Typically, things that have a power factor naturally of 1.0 are things like resistive loads. And I've written resistive load down here on the post-it note. A really good example that everyone will be familiar with is an incandescent light bulb, which just has a coil inside that heats up really to make the light. That is a resistive load, and its current draw follows exactly the AC waveform of the voltage. So its power factor is a perfect 1.0. So with a 60 watt light bulb, because we know the power factor is a 1.0, that means that the VA of a 60 watt light bulb is also 60. So watts equals VA when the power factor is 1.0. Things start to get a lot more complicated when you have something like a switching power supply. Now this is a very small switching power supply, but say you have like a 300 watt power supply inside of a computer. You can't just take the 300 watts and assume that you can convert that to VA by just looking at watts equals VA. It's not that simple. And that's because the power factor has to be taken into account. And if we look at this diagram right here, the AC voltage in my house, I've drawn that as that same AC waveform that's on this other post-it note. But with a switching power supply, it's a little more complicated due to the way it switches in and out the transistors or the MOSFET as to how it draws current from the line. Now I have just drawn an example of the current draw. This doesn't actually represent anything in particular. And I've written down here power factor of 0.4. But you see how these spikes, they don't follow the waveform. They just sort of shoot up and then they head back down again. The transformer is going to have to handle these current spikes, which can go far in excess of the average current draw that you might be measuring. So if we measure 1 amp as an average, the fact that it's spiking way up here and then there's nothing means that this actually could be drawing 2, 3, 4 amps during these spikes. And the transformer and the line cords that are connecting it, they have to be able to handle those current draws. With a device like a kilowatt, and these things are pretty commonly available, it can measure watts, amps, volts, and also show you the power factor. Now imagine my theoretical power supply that is hooked up to the isolation transformer here is running at 120 watts. Because it's not a resistive load, it's not 120 VA. Because the current waveform is very spiky, let's theoretically say that with some measurement, we determine the power factor is actually 0.4. Now going back to the calculation here, we can solve for the number of VA that our 120 watt power supply with a bad power factor of 0.4 actually uses. So we know we have 120 watts, that's what it says on the label, and we know the power factor is 0.4, and what we need to do is solve for the number of VA so that we can make sure that this device is actually going to work and not exceed the capacity of my isolation transformer here. So let's just solve for that. We'll use my calculator. This is my smartphone, and I'm running RealCalc here, which is an awesome, awesome calculator for Android. And yes, it's in RPN mode, which is what I learned to calculate on in college. I use an HP 48G. I think I've talked about that on the channel before, but this is a very great calculator that I love. I use this all the time. Anyhow, let's just quickly solve for what the number of VA is so we know if my theoretical power supply can work on this isolation transformer. So all we have to do is divide 120 by 0.4, and that gives us 300 VA. So our crappy power supply with a bad power factor actually could draw up to 300 VA, which still is within the limit of this transformer, but just. If we plug this theoretical power supply into here, we could switch to PF power factor and measure the power factor, but we could also press the VA button and actually just read the VA directly, which would help us avoid doing a little bit of math here. But the problem is the power factor might be 0.4 most of the time just because of the way the power supply works. But unless you load that power supply up as hard as you can, it'll be hard to get an accurate VA rating. But using the power factor even at a lesser load and then the wattage that's on the label of the power supply, you can make a rough calculation like we did right here to make sure that you're not going to exceed the maximum capacity of the isolation transformer or the UPS. Okay, I want to do a quick test. So this is the backside of an Apple color monitor. Well, let's plug this into the kilowatt, which I have sort of off camera. Unfortunately, you're not going to be able to read it. And let's turn this on and check out what its power factor is, check out how many watts it uses, and then we'll look at the amount of amps it uses, see what it matches to the label here, and then we'll check out the VA, and we'll see if it fits within the power budget of this isolation transformer. All right, so hopefully you can even see that at all, but it says here it's using 40 watts, so 40. Let's check out the volts in my house, 122.3. So if we just stop there and we take our 40 watts and we make some kind of assumption that watts is the same as VA, ignoring the power factor, and we're going to say, okay, well, 40 watts completely fits within the budget of the isolation transformer, we still could become a gutser. And that's as Dave Jones from EE Vlog says. I don't think we're going to with this monitor, but like we check here and we go to power factor on this monitor is a pretty terrible 0.50, 0.49 actually just went down a little bit. So on here, if we go 0.49 and we do our reverse calculation here that we did a little while ago, and we try to figure out what the VA is, well, with the simple formula watts equals VA times PF, all we have to do is take the 40 and divide that by the 0.49, and that's going to give us 81.63 VA, twice as many as we might have thought if we just assumed that watts was the same thing as VA. And one thing to consider for this monitor, 81.6 VA, is the monitor is showing nothing on screen right now. It's black because I don't have anything hooked up to it. It will draw more current, it will use more power when there's something displayed on screen. So this will likely be higher. So let's push the VA button on this device here. So 40 watts. And there it is, hopefully it's visible. It says 81 VA. So that is a very useful device for quickly figuring out how many VA something is using. So unplugging the monitor from the kilowatt, if I connect it to this isolation transformer here, like so, I am confident that the 81 VA that this monitor uses, at least when it's idle, fits within the 300 VA rating of the transformer. Let me turn on the monitor. Now this thing is making a humming noise, which is normal for transformers, and when I turned on the monitor, the humming changed. But the monitor is on, I can hear that it's running right now, and this thing sounds fine. If this were running near its maximum load, it will start to get warm. It will start to get hot. Running a transformer beyond its rated capacity, so we go over 300 VA, is not gonna just stop working. It'll continue to work. I don't think there's a fuse on here. It doesn't seem that there's one. But it starts to saturate and the waveform gets distorted, and it's not ideal. You want to try to stay within the rating of a device like this. Now I'm hoping that my explanation of the relation of power factor, VA, watts makes sense, and how that relates to the VA rating of a UPS or the isolation transformer. And I hope it makes sense even how I explained what an isolation transformer does in the first place. And there may be some of my viewers that are lost. I implore you, it's very fascinating. Go check out Wikipedia and read up about this stuff. It's pretty interesting. It's totally my intention to take this isolation transformer and mount it to the wooden wall that's behind my desk here, and then run an outlet with a switch so I can turn this off and on, because it does consume some electricity just being connected to the mains, and it makes a buzzing noise as well. So I want to be able to turn this off and then turn it on when I want to use it, and then plug a device under test into that outlet. And as I had mentioned before, I've already been using this thing. Obviously it's not installed. I need to go buy some hardware to get this thing mounted with the outlets and stuff, but I've already been using it and my safety has been improved. And that's all thanks to Chris, who thought about me and my safety and sent this in to Mail Call. So thanks very much, Chris. I really appreciate it. And that's gonna be it for this Mail Call episode. I hope you enjoyed it. And if you did, I'd appreciate a thumbs up. But if you didn't, you know what to do, all that YouTube-y stuff. And that's gonna be it. Stay healthy, stay safe, and I'll see you next time. Goodbye.